Hello everyone, welcome to day 11 of Java coding, and right now it's processing coding. Today we're going to be working on adding, collision detection, and any other little bits that we want to add in, like menus or game over signs. And so, you know what, let's not waste any time, let's just hop right in. So I have my code here. You can see that it still runs. We have our little Flappy Bird game from last time, but you notice that it doesn't have any game over. Wow, I am horrible at this game. Uh, it doesn't have any over signs, and it doesn't have any points either. So we will work on adding those two in today. Oh, let me press the stop button, not the play button. Okay, so we have to go over collisions, and so I might have to draw some things on the whiteboard. Let's do that right now. Okay. So, what are we gonna have to have? Okay, let's draw our. Can I adjust this? Okay. What are we gonna have to have? This is our screen, right? And we have our bird. Maybe that's too big. It doesn't matter. So, how do we detect whether or not the little bird is inside of these rectangles? Well, we do a bunch of math, and it's just a bunch of comparison math. It's not that hard. So basically, we can the way how do you detect collisions, right? The first insight is say, hey, check every single point inside of this circle and see if any of those points are touching any point inside of these rectangles. And obviously, that's not very efficient. So what we're gonna do instead, and also, what we're gonna do instead is a thing I call just point detection. And so, let's say instead of using a circle, we're gonna give this a collider, right? Or basically, how we're gonna check it in comparison to these two rectangles, we're gonna give it a rectangle, and that just makes doing the math and checking the points a lot easier. And I will show you guys why. So instead of checking every single point on every single one of these shapes, we're just gonna check the corners, or corner detection. Sorry, not point detection. I call it corner detection. Basically, you check whether or not this point is inside of this box, which is relatively easy to do. You just do a bunch of comparisons. Then you check this point, this corner, and then this corner, and then this corner. And so we can get these corners really easily. We can get the coordinates for them really easily. All we have to do is check all of them and see whether or not they're inside these pipes. So that's what we're going to be working on today. Now, if you end up trying to do it with a circle, you're going to have to do some, like trigonometry or whatever, or just basic geometry. But just using corners is a lot easier. And the reason I use corners is because as long as there's no turning of the rectangles, as long as the rectangles can't like rotate and form like diamonds, uh, as long as the corner is touching inside of it, as long as the corner is touching, that means they're colliding. And so it can't, as long as our rectangles aren't turning, there's no way for this box to touch this rectangle or square without touching one of the corners. And see, if it's like this, then it can like pierce through. It can check here, and avoid. It can collide, but avoid checking the corners. But if it's like another rectangle, it can't collide with it without touching one of the corners. So we're going to check whether or not the corners are inside either of these two rectangles. Okay, I'll leave that up for now. So how are we going to do that? Well, first, let's add a function into our pipe. We're going to have each pipe return a Boolean value, a yes or no, a true or false, depending on whether or not a certain point is touching it. So we're going to define a new function. We're going to call it checkpoint. Not like a checkpoint, it's a checkpoint. You're going to get the float x, float y, basically the coordinates, and you're going to see whether or not that coordinate is inside either of the two pipes. And because this stores both pipes, we can use this one function to check. Okay, so first let's check. What are the different values we're gonna have to check? Back to the whiteboard. All right. So, I have to do one more thing before we do that. Okay. Well, one more thing I'm gonna do is I'm gonna go back to our bird class, I'm gonna give it more variables. Right now we only have a y value. That's the only thing that defines the dimensions of our bird. But I also want to have an x, a width, and a height. And the reason I want the reason I type w instead of width is because width defines the entire dimension of the width of the screen, basically the width of the screen. And the reason I want all these values is so it's easier for them to be passed into the pipe, or it's easier for our bird to remember, and it's also easier to change them. And what I mean is, hey, when I give my bird an x, right, I'm gonna give it an x right here, and I don't want to change it. And I'm gonna give it a width right here, and I don't want to change it, and a height. The only thing I'm changing is the y. And that way, when I print all these values out and I draw the ellipse, I could just say this dot x, this dot y, this dot width, right, and this dot height. So, yeah, again, I'm not changing the x, width, or height. I'm simply storing them inside of the bird, giving it those properties. Okay, now let's go into collision, right? So, how do I check whether or not the pipe is, or how do I check whether or not a point is inside of the pipe? Well, again, maybe I didn't have to erase that. All right, whatever. We have our pipe. Oh man. Now, how do we check if this point is inside of that pipe? Well, we have the dimensions of the pipe, right? This is its x value. What is this value right here? The other side of the rectangle. It's x plus the width of the height. The width of the rectangle. What is this value right here? We check all the boundaries. That's what I'm trying to say. We check all the boundaries and see if it's within those boundaries. This value is, we call this value, or this height right here, we called it space. Oh my. We called it space, which means this value is space plus space width. Space plus space width. Space plus space width. And this is just height. So we have to check whether or not it's inside of all these boundaries. Okay, back to the code. Alright, I probably didn't have to have that be so visual, but it's good for us. It's good for us. Okay, so we're gonna say, hey, is the x that was given to us, is it greater than this dot x, or greater than or equal to this dot x? So is it to the right of this boundary, this line right here, if you can see, to the very left line of the pipe? It also has to be less than the right side of the pipe, right? It has to be within that boundary. So it has to be less than this dot x plus this dot width. And what this sign here means is, if you don't remember the comparison operator episode that day, this symbol means and. It means all of this symbol right here. Okay, yeah, this symbol right here and this symbol has to be true. Excuse me. Yeah, this operator and this operator have to return true in order for it to return true. Excuse me. So it has to be to the right of the left side and to the left of the right side. And we define the width here, so we don't have to worry about that. And now we have to check for the y. Is the y less than this dot space? Is it above this space, right? Or, yeah, I have to put equal signs as well, because if it's touching, we have to have it be a collision as well. So this isn't the most beautiful collision detection because it's very rough. I'm using corner detection on rectangles, so it's very easy for it to just bump into it, like one of the to the pipes without, and the collision's like a little off. It might like be a little rough, but that's okay. So it has to be less than this dot space, and it also has to be greater than or equal to 0. Yeah. So it has to be, above. It can't go above. I mean, I don't necessarily have to put y is greater than or equal to 0, because it'll always be greater than or equal to 0. It'll always, we defined it earlier that it has to, like, be below the window. It has to base the why. This is just saying it has to be below the window. So that's true. Return true. Right? It's touching. Now, if that's not true, now we have to check the lower rectangle. We have to check this rectangle. So the width and the x dimensions are actually the same. So we can just kind of copy paste that in. Is less than this dot x plus this dot w. But instead of saying, hey, it has to be less than this dot space, it has to be actually greater than this dot space with this dot space plus this dot space with, right? It has to be greater than. If you remember, y values actually increase going downwards. So it has to be greater than this value, which is space plus space width. And it has to be less than height. Just to keep things consistent. Less than or equal to height, you know. We're checking all sides of the rectangles. So if that's true, return true. Oh, what did I do wrong? Oh, else if, sorry. Else if. And if none of those are true, which means it's not touching either rectangle, return false. Okay, so we have this checkpoint function. So now we have to have this function check every pipe at every frame for the bird. How do we do that? We're back at our Flappy Bird, the main class, right? The one that manages all this stuff. Now I could just say, I could check it all here. Say, hey, is the left corner of the bird inside of the pipe? Is the right corner of the bird inside the pipe? But I'm gonna just make a new function for our bird. Hey, void check pipe. Wait, I'm just gonna call it check. Right? I'm gonna give it a pipe. Oh, okay, it won't be void. It'll actually return boolean as well. So check. Yeah, I'm gonna call it check. And inside, I'm actually gonna give it a pipe. And what that means is, hey, I can just give my bird the pipe that I'm looping through. I'm looping through all the pipes in this function right here. So if I loop through all of them, I can give each pipe to the bird function, and the bird function will do all the work for me. I don't have to. We want to avoid making this file as messy as possible. And the reason you don't want to make this file as messy as possible is because it's a lot harder for other people to read if this file is really messy. So because it's the main file. So we're gonna say, hey, if if pipe dot checkpoint I have to give an x and y, this dot x, this dot y. If that's true, go ahead and return true. Okay, so why can I just say this here? This is giving me back true or false, which means, and all the if statement needs is true or false. Now I could have written if this equals true, right? But that's sort of unnecessary, because if this equals true, if true equals true, it'll give you true. If false equals true, it'll give you false. So we can just avoid that completely, and we're saying, hey, is this function that we're calling returning true? If so, give us a true and return true again. So that probably made no sense, but it's good for us. Okay. Now you see I'm getting an error, and the reason is because our function isn't returning a value every time. Boolean means it has. When I say boolean here, I'm saying this function has to return a boolean. So we have to make sure that this function always returns a value. So let's go ahead and check again. Hey, if the top left corner, which is x and y, if that's not inside of the pipe, let's check the top right corner. Let's check the top right corner. And the top right corner is the x value, right, plus the width. The x value plus the width will give you the right hand side. Yeah. Return true. And now if that's not true, let's check the bottom left corner. Pipe dot checkpoint. So it has the x value of. Now, I'm doing this very quickly, but you can take your time and go and visualize what these values mean. This x and this y, and what happens when you add to it. And I'm saying, oh, it's just the right-hand side. If you can really visualize that for yourself, that would really help you when you're creating games like this, or applications in general. So, how do you get the bottom left side? The height, the y value plus the height will give you the x coordinate of the bottom side. So I'm gonna draw this out for you, but for now let me just code it in. So now we're gonna have to check the bottom left corner. That's the last one. Okay. Come on, stop wasting time, Luke. This dot y plus this dot height. So yeah, that's the last corner. Return true. Now if it's not touching any of those, we're gonna say else, return false. It's not, none of the corners are touching. So let me draw that out real quick. So we have our bird, right, which has a width and a height. And usually circles are defined by like a radius, but in part processing, we just say how tall and how wide it is. So it has the dimensions of a rectangle. So this is our x value and y value, right? This is the coordinate we drew the ellipse at, or the rectangle. This is x and y. And this is the width and the height. The width and the height. So how do we get this corner here? How do we get the coordinates for that corner? It's just x plus y, or x plus width, to get this side. And to get this side, it's y plus height. Y plus height. And to get both sides, it's this value and this value. So yeah, just a little bit of coordinate geometry. Coordinate geometry as in just adding up the widths and heights to coordinates. Wow, my hair is really messy today, but that's okay. So back to the code. Now, we created our check function. We created the check function for the pipe, whether or not a point was inside of the pipe. We created a check function for our bird, whether or not the bird was touching any of the pipes. Now we just have to call it for every pipe. Hey, if the bird, right, we define our bird up here. We have a bird. Hey, if that bird is touching any of the pipes, right? And how do we get each pipe? Pipes.get of I will give us each pipe, because we're looping over all of the pipes with the index I. Then we have to do something about game over. What I mean by that is now we have to add in a variable that will tell us whether or not the game is over, or yeah, whether or not you failed, right? You died, you lost. So let's create one more variable up here. We're just gonna call it Boolean game over, and the reason I give it Boolean is because game over will only have a value of true or false. Is the game over? True or false? And we're just gonna define that up here. Game over equals false. If the game is not over yet. And if it's touching the pipes, we're gonna say game over equals true. That way, now our game knows that the game is over. So what do we want to stop? Because when the game is over, we have to stop some of the functions, right? We can't have you be able to jump while the game is over. So we're gonna say and not game over. Okay, again, this and means both of these have to be true. So if one of these is false, it's not gonna work. Not game over means, hey, if it's not game over, and the exclamation mark, which is called bang in coding, if the game it means not. The exclamation mark means not. So you can it basically flips a switch. If you have a true, it turns into false. If you have a false, it turns into true. So I'm basically saying, hey, in order to jump, you have to press a space bar, and the game has to not be over. Excuse me. So we also don't want to add pipes when the game is over. We also don't want to update the bird. Now this is the reason why we have a update function and a show function. what if we want to freeze the bird in place so it's not the gravity is not affecting it, but we still want to show it to the screen? Then we could say if not game over, and we're basically wrapping bird update inside of here. We're saying, hey, only allow gravity to affect it if the game is not over. Where else do we have to add it? The pipes. We don't want the pipes to be moving if not game over. Yeah, that's it. That's all we have to do. And also, we're gonna add one last thing at the very end to show us, just to make things clearer, when the game is over. So if it is game over, what do we want to do? We're gonna say there's a couple of functions that you can use to help add text to the screen. So I'm gonna show you them right now. How to add text to the screen. This is amazing. You can say first we're gonna say text size, right? We want the size to be around 16, just to keep it standard. Now text align. We're saying, hey, if I draw a coordinate, draw a coordinate for the text, I want the text to be centered around this coordinate. Otherwise, it would automatically align left. And what that means is, if I define the coordinate for the text here, it would write it out to the right of it. And you'll see what I mean very soon. So center has to be capitals. Now, in regular Java, you would not be able to use these functions. These are special functions that processing allows us to use in order to help make adding GUI elements, or graphical user interface elements, just image elements. It makes it a lot easier. And center is a variable that our game already knows, or our processing already knows. It's a variable that it's given us, kind of like width, kind of like all the functions like setup and draw. It's another tool that processing gives us, and you'll see why I use it very soon. So now we can just say text, right? When you say text, it takes in three things. It takes in the string you want to say, game over, where you want to place it, the coordinate, and the height, the width of the coordinate and the height of that coordinate, or the x of the coordinate and the y of the coordinate. So I want it to be placed in the center of the screen. Now, a lot of that was very abstract, as in you couldn't really see it in action. So let's go ahead and run the game. What did I do wrong? Oh, okay, forgot a parentheses. Okay, I was missing parentheses. No? Luke failing again. I don't like you. Oh, okay. Sorry, I missed out on one of the curly brackets. My bad. All right, so let's play a game. Game over instantly. I failed. So one last thing. One last thing to make this a lot easier. We're gonna say fill, which means when we draw something, we're gonna give it a color. Let's just give it red. RGB. More red means more red. So let's. Oh man, I didn't even get to play. So it works. You can see that the collision is a little bit off because the circle is drawn differently than the rectangle that we're detecting, but it's close enough, and that's all we're going for here. And so you see that when I touch the pipe, I game over. Okay. Now, the reason you don't see me jumping, it's because I'm really bad at the game. No, it's because I'm having trouble here. Okay. Because my my mouse cursor is not focusing on this. Okay, I got this. Okay, I'm really bad at the game, obviously, but we're gonna add in that's basically it for today. We added in collisions, and next time we will be adding in menu elements and the score. That's, again, thank you guys so much for watching. That was a lot of math. It was sort of difficult. I went over it pretty quick. Ask me any questions if you need. You know how to contact me. I will see you guys very soon in the next video.